Before we can discuss what the humanities are, we first have to get a definition of what a human being is. The most succinct and powerful definition comes from Charles Darwin's idea of evolution. Evolution, the process by which different kinds of living organisms are thought to have developed and diversified from earlier forms during the history of Earth. Darwin's idea of evolution was controversial when it first came out, and it still causes controversy over 100 years later. We are descended through the process of mutation from earlier forms of hominids. This class is going to explore part of this early evolution, and in particular, the development of the most important resource of human beings, our brain. Many people think that evolution is false because it is spread out for so long a distance in time. Literally, human beings evolved over tens of millions of years. However, a more compressed version of understanding evolution can be found in a simple diagram of the cell foam. In short, evolution suggests that everything moves from simplicity to complexity. So we move from a simpler form of life, the simpler primate, to an ever more complicated primate. In the same way that when you look at earlier forms of technology, they evolve to become ever more complicated. Evolution, thus, is a natural force in biology that moves through mutation. It is also found in our technology. As you can see by this image, human beings, or rather Homo sapien, which is a scientific categorization, have evolved about through many different models, and this particular model looks at the development of the human skull. Inside the human skull is the most important machine, biological machine, in the world and perhaps in the universe, which is the human brain. Robin Dunbar is an evolutionary biologist that studied the human brain, and he came up with what is called Dunbar's number. Dunbar's number is a suggested cognitive limit to the number of people with whom one can maintain stable social relationships. These are relationships in which an individual knows who each person is and how each person relates to every other person. The Dunbar's number is based upon a threshold that people feel comfortable, the number of people that we interact with, primarily with family and with friends. By understanding the cognitive upper limit of 150, we realize that in situations that are in excess of 150, it can be a situation that causes anxiety to people. Larger brains, of course, require larger skulls. Larger skulls, in turn, require a larger birth canal. The anatomy and pelvis of women is more elastic in the pubic area and also in the birth canal. The key to understanding human beings' success on the planet is understanding the success of our brain. And evolutionary biologists and scientists have spent a lot of time trying to understand how our brain came about. Evolution is the most direct way of expressing that, to say that there were earlier models that evolved through mutation into larger and more complicated models that eventually gave way to the modern Homo sapien. That is to say, human beings, the modern human beings, you and I. The size of our skull and the corresponding size of our brain has allowed Homo sapiens to create a unique and vibrant culture. We hunt, gather, use fire, use tools, and create art. Unlike any other species on the planet, this makes us unique, and it all goes back to the size of our brain. This brain is therefore the starting point for our class. It is the origin story for the humanities itself. Let's apply what we know about the human brain and Dunbar's number, again 150, to understanding how social systems work. At the number 5, we have intimates. The number 15, close personal friends. 150, friends. Then outside, we get to acquaintances at 500 and strangers. What this means is it's our comfort zone. Literally, our brains are more comfortable with fewer than 150 people. From Dunbar's number, we can extrapolate that in large gatherings, people often feel nervous and or overwhelmed. And this is completely natural, as we have evolved to organize and to naturally mingle with groups under 150. To some extent, we can understand that human beings get stressed out when we're in large groups. Theorizing even larger, we can come to the conclusion that populations in excess of 150 are inherently unstable, at least from the position of Dunbar's reasoning. From another vantage point, we can then look towards symbols. And symbols were devised to transcend Dunbar's number and unite crowds. Using these ideas around evolution, the evolutionary brain, and Dunbar's number, we can come to the conclusion that human beings are unique among animals on the planet and that we respond very specifically to symbols. We unite around symbols. And unlike other animals, we are quite willing to kill for our symbols. And now we're going to move on to another model of behavior predicted by evolution, and that has to do with the triune brain. The triune brain is a model of the evolution of the vertebrate forebrain and behavior proposed by the American physician and neuroscientist Paul D. MacLean. MacLean originally formulated his model in the 1960s and propounded it at length in his 1990 book, The Triune Brain in Evolution. And this is a basic imaging of the triune brain, and the word triune is a fancy word for three, and Paul MacLean suggested that the brain has evolved into three primary sections. The red section is called the reptilian brain, and it's safety, sustenance, sex, and procreation. The yellow part is our animal brain, is also called the mammalian and limbic, and that is responsible for love and emotion. And then we have the final part, which is the green portion, for intellectual tasks, thought, word, deed, and creation, and is often called the neocortex. There have been modifications to MacLean's original ideas so that people are interpreting it slightly different, but this is a way of thinking it in broad strokes. So the reptilian brain is the decision-making brain, the middle brain is the emotional brain, and the top brain, our neocortex, the new brain, is where we do the rational thinking. If we just focus on the reptilian brain, which means that we have a brain in common with all reptiles on the planet, so in fact we are able to think like a Tyrannosaurus rex on the most basic level, it's responsible for fight, flight, freeze, sex, and ritual. Here's a more elaborate mapping of the triune brain theory, and you can see the lizard brain section, the brainstem and cerebellum is fight or flight, it's autopilot. The middle one here, named the mammal brain, we share that with porpoises and monkeys and dogs and cats. The mammal brain is the limbic system and has emotions, memories, and habits. It also has decisions. The human brain, which is ours alone, is the neocortex, language, abstract thought, imagination, consciousness, and it reasons and rationalizes. So when we get to the idea, what makes us truly human, it is the neocortex that allows us to think, to use abstraction, to imagine, and use consciousness. That makes us different than all of the other animals on the planet. And here we have another way of looking at it, and I want to focus between the triune brain and the conscious and the unconscious. The neocortex is our conscious brain. The limbic system and the reptilian brain are our unconscious brain. So in the rational brain, reading from the middle, we're verbal, word-based, higher intelligent patterns, emotions, working memory, high involvement processing, active learning. The metaphorical brain, which is the unconscious part, is nonverbal, image, sensation-based, base patterns, long-term memory, low involvement processing, passive learning, instincts, basic instincts, impulses, and reflexes. So this is a clearer way that the higher part of our brain, what we consider to be our human part, is the one that is conscious. The lower part of our brain, which is the more animal part, is unconscious. Now, let's put some numbers to the evolutionary brain, and we're going to look at the top here, the R complex. The reptile evolved during the Triassic period, 248 to 206 million years ago, regulates hunger, temperature control, fight or flight responses shared with reptiles such as fish. Now, that's a long time ago. Let's say ballpark it at 225 million years. So our brain is a very old, evolved machine. The limbic system, which is the second part of our brain, evolved during the Jurassic period, some 260 to 144 million years ago, regulates mood, memory, and hormone control, shared with older mammals such as dogs, cats, and mice. And then, last but not least, of course, the neocortex, that which makes us truly human, evolved during the Eocene and Oligocene epochs 55 to 24 million years ago, regulates logic and thought required for complex social situations, etc., shared with monkeys and chimpanzees. And here we have a basic breakdown of the behavioral traits for each portion of the brain, of the triune brain. The neocortex, behavior traits, language, abstract reasoning, logic. Limbic brain, behavior traits, memory, emotion, bonding, and family. Reptilian behavior traits, survival, reproduction, fight or flight, territory, and domination. Now, once we understand that the brain is a key to understanding human beings and behavior in general, we can start to look at images and put each of the images into one section of the triune brain. So here we're looking at this conflict between a dog and a cat, and the dog is reeling backwards. Now we're looking at the reptilian brain because it's a fight or flight situation. Here again, we have a conflict between the jackal and the vulture. And again, we can say that this is a reptilian type emotional response, which is built into fight or flight. Here's another one, a humorous example of some photographers who get startled by a bear. And just like the preceding images, we're looking at a response to the reptilian brain, which is fight or flight. Now, here's an image to provoke. You're looking at an image of a wolf. Do you fight or do you flight? Once you look at the world from the position of a triune perspective, you should be able to recategorize images into the appropriate section of the brain. This is an image I got from a video game. And video games are largely behavioral patterns based in the reptilian brain. They're mostly about fighting or flighting. So in this case, before I took on this zombie, I might want to check what I had in my arsenal. If all I had was a pencil, I might want to look around and see if I could get something a little more hefty like a wrench. Do you fight or flight? This is an image of Samara from a supernatural horror film called The Ring. Do you fight or flight? And this is one of her victims. Do you fight or flight? So each of these images should provoke an automatic response inside of your brain. And if it's autonomous or automatic, then we could say that the reptilian is operating on an unconscious level. So unconsciously, your brain decides if you should try to fight this supernatural creature or if it's time to run away. The limbic brain is probably the one that's the happiest part of our brain, and it's about family, love, and bonding. It is inherently about memory, and it's about whether you're sad or whether you're unhappy. Question: is mood outside of your control? This is a difficult one to answer. Are you in control of your moods? Most people are trying to maintain a happy state of mind, but just waking up in the morning and saying, I will be happy all day long, does not guarantee it's going to happen. To a certain extent, happiness and emotions are within and also without our control. I hate my moods. They never ask permission before they change. We get down to the human part of the brain, the neocortex. Here is represented by Spock, who is in all logic. Here's abstract reasoning, which is chess. Something you can't really get monkeys or dogs to play chess because it's an abstract board dealing with principles that are appealing to human beings. Here's an example of neocortex thought. So if you had to solve for the equation in order to find out the speed limit. Investigate, reason, review, analyze. This is what the neocortex is exceptionally good at doing. And here's a quote from Albert Einstein. I never made one of my discoveries through the process of rational thinking, which means that Albert Einstein was thinking holistically and integrating all portions of the brain. And this is something that's important to consider too, that we don't always react to situations with just one part of the brain, that in fact we may react with an entire spectrum of thinking across the reptilian, the limbic, and the neocortex as well. So when you're armed with this knowledge, and you can look at images completely different from a more anthropological and scientific perspective, which brain, reptilian, limbic, neocortex. Now, not every image you look at is going to be very obvious. In this case, I would say because of the idea of them wearing uniforms, the idea of them being bonded, it's definitely a limbic. I don't understand the context for it, but definitely they are all working towards the same goal.